All right, pre-algebra, moving on to the second part of our lesson. This is all about square roots and cube roots. So we should, in order to be successful, we should be able to determine the square roots and cube roots of rational and irrational numbers. So that's going to involve squaring a number, squares and square roots, and cubes and cube roots. Again, following along with your guided notes is how you are going to be most successful in this lesson. Let's get started. So, squaring a number. So in our review of exponents, we know that squaring a number is raising that number to a power of 2. For instance, if you have the number 8 to the power of 2, that just means 8 squared, or 8 times itself. 8 times 8, 8 squared would be 64. When a negative value is squared, we need to make sure to note whether or not the negative sign is inside the parentheses. That makes a very big difference. For example, negative 2 squared just means negative 2 times negative 2. Again, the negative is inside the parentheses with the 2. We are squaring negative 2. We know that a negative times a negative is a positive. So negative 2 squared would be positive 4. Same thing with negative 3 squared and negative 4 squared. Negative 3 squared would be positive 9. And negative 4 squared would be positive 16. Now let's look at these. Notice how the negative is not inside the parentheses, which means we're not actually squaring the negative. This is the same as writing negative 2 times 2. So the outcome will always be negative in this case. So negative 2 squared would be negative 4, because 2 times 2 is positive 4, and then add the negative at the end. Negative 3 squared would be negative 9, and negative 4 squared would be negative 16. Again, very important to note whether the negative sign is inside or outside the parentheses when you multiply. Let's talk about squares and square roots. So squaring a number is the inverse or opposite of taking the square root. So when we take the square root of a number, this technically results in 2 solutions. So for example, the square root of 16 is 4, or it's negative 4, because 4 squared is equal to 16, and with parentheses, negative 4 squared is 16. Remember, a negative times a negative is always positive. The positive square root is known as the principal square root. When we use the radical sign, that means the solution is the positive square root. So for instance, the square root of 64, this is the principal square root of 64. So the only answer I'm looking for here is the positive one. The answer would be 8. That's the positive square root of this number. Now let's quickly talk about cubes and cube roots. So cubing a number, or raising a number to a power of 3, raising a number to the power of 3 is the inverse of taking the cube root. So before we go further, let's talk about what cubing a number means. So let's say we have 3 to the power of 3. This just means 3 times itself 3 times. And 3 times 3 times 3 would be 27. Cube root is the inverse. So let's say the cube root of 27 would be, well, we're asking what number times itself 3 times is 27, and that answer is 3. Another example, the cube root of 8, the number that multiplies by itself 3 times to equal 8 is actually 2, because 2 times 2 times 2 is equal to 8. Now here's an interesting question. Can a cube root of a positive value ever have a negative solution? Let's think about this. We know that squaring a number can have 2 outcomes because a negative number times a negative number is always positive. Let's test this out. Let's say we have 8 cubed, and let's say 8 times 8 times 8. That's always going to be positive. If we have negative 8 cubed, that's going to be negative 8 times negative 8 times negative 8. Now, without even doing the math, I know that a negative number times a negative number is positive, and then we're going to multiply it by another negative number. So honestly, if you are cubing a negative number, the result will always be negative. If you're cubing a positive number, the result will always be positive. So can a cube root of a positive value ever have a negative solution? We just proved it. No, it cannot. That will never happen. All right, so what's really going to help us moving through this module is having a reference for the first 10 perfect squares and cubes. That means integers, when you square them, the values that you get when you square them are perfect squares and cubes. So when you see 1 squared, that just means 1 times 1. That's, of course, 1. When you see 2 squared, that's 2 times 2. That value would be 4. 1 cubed is just 1 times itself 3 times. That's, of course, 1. And then 2 to the 3rd power, or 2 cubed, is 2 times 2 times 2. That would be 8. So stop here and fill those in, and then come back in a second to check your answer. And here is that table filled in. So let's practice with squares and square roots. This is only a few examples, so really we want to make sure we are doing the additional practice here. So let's say we have -6 squared. Again, notice the negative sign is not inside parentheses. So what we're actually going to be doing is negative +6 times +6. We are only squaring the +6. 6 times 6 is 36, but then we have to make that negative. So our answer is -36. Now let's say we have a fraction and we need to take the square root of that fraction. Here's how that actually works. I'm going to take the square root of the numerator and denominator separately. So the square root of 4, when we look at this, it's asking what number times itself equals 4. And this is the principal root, the positive root. The square root of 4 is 2, because 2 times itself is 4. The square root of 9 is 3, because 3 times itself is 9. So the square root of 4/9 is actually 2/3. There are a few other practice problems here. That would be problems 1, 2, 4, and 5 to practice with squares and square roots. Now for cubes and cube roots, let's take a look. Let's say we want to cube a fraction. Well, we're cubing the numerator and we're cubing the denominator. So this would be 1 times 1 times 1 over 4 times 4 times 4. And when we simplify that, that comes to be 1 over, well, 4 times 4 is 16, and 16 times 4 is 64. So 1/4 cubed is 1/64. Now let's try a cube root. Remember, the 3 inside the radical symbol just means cube root. So we want the negative cube root of 512. The negative cube root of 512. Well, I know that there is a number when multiplied by itself 3 times equals 512. That number is 8. The cube root of 512 is 8, but I have to make it negative. So the negative cube root of 512 is negative 8. There are additional practice for cubes and cube roots on our notes. That's problems 7, 9, 10, and 12. And there are 2 additional practice problems at the end of our notes. So that was it for part 2. So thank you for watching. Again, make sure you're doing those practice problems. Check your answers with my filled in notes later. Those are located in the content library of our class notebook in the Module 1 Notes tab. Please just make sure you're asking for support in the Math Help Desk if you need it, and I hope you have a lovely, lovely day.